Alrighty folks, in this video I want to go over relations and functions. So we're going to kick things off with a few definitions, get into some examples, and hoping you can get through your homework. So let's start off with a Cartesian plane. So a Cartesian plane, so a plane in mathematics is just whenever you have axes, different axes. So a Cartesian plane is where you have two axes. You have your horizontal axis and your vertical axis. All right. Your horizontal axis, that's home to your independent variable. We most of the time refer to that as the x-axis, but it could be any variable, any letter. But the horizontal axis is home to the independent variable. The vertical axis is where you have your dependent variable. Okay, most of the time we're going to refer to that as the y variable. An ordered pair, so it gets its name because the order in which we see numbers in an ordered pair, it makes a difference. We do not plot 1, 2 in the same position as 2, 1. So an ordered pair consists of two parts, right? The first value represents your independent variable, the x variable, and the second number in an ordered pair represents your dependent value, aka your y value. All right, a few more definitions. So the set of independent values, the set of all x values or inputs, sometimes we refer to them as, is called the domain. So the set of all x values is your domain, whereas the set of all dependent values, which are your y values, is referred to as your range. And lastly, we say a set of ordered pairs. We call that collective set a relation. All right. So for example here. For example, we have a following relation. We have three ordered pairs. We have 1, -3, 0, 2, 4, 1. And what they want us to do here is to identify the domain and the range for that relation. Okay, so what's our domain? The domain is a set of all, so curly brackets denote a set. It's a set of all independent values, in this case x values. So our domain should be the values of 1, 0, and 4. Whereas our range will be the set, the y values, -3, 2, and 1. Okay, we have to list out those values separately in this particular example here. All right, so a function is a relationship in which there can only be one dependent value, there can only be one y value assigned to each x value. Okay, there can only be one y value assigned to each x value. All right, so for example here, consider this following relationship. Okay, so what I have here is already drawn it out for us, is we have the set of x's, which we call the domain, is 1, 2, and 3. The set of y's, the range is 4, 6, and 9. And so if you notice here, the ordered pairs, if we were to write out the ordered pairs that is exhibited by this relationship, is the ordered pairs would be 1, 4, 2, 6, or excuse me, 2, 9, and 3, 6. Right? Those are the ordered pairs illustrated by that diagram there. The question here is this relation. Is it indicative of a function? Is it a function? Well, go back to our definition. For each x value, it can only be assigned to one y value. There can only be one y value assigned to each x value. So as we go through, 1 is assigned to just 4, 2 is assigned to just 9, 3 is assigned to just 6. So because of that, it satisfies our definition. Yes, this is a function. Okay? There's only one y assignment for each x value. There's only one y assignment for each x value. All right, how about this one? All right, let's do the same thing. Let's write the ordered pairs for this example. So what are the ordered pairs for this example? They would be 1, 4, 2, 4, and then 3, 9. All right, same question. Is this relationship a function? We'll go back to our definition. Our definition says there can only be one y assignment for each x value. Well, ask yourself, for 1, the x value of 1, what's its assignment? Its assignment is just 4. That's one assignment. Go to x value of 2. 2 is assigned to just 4. That's okay. And then 3 is assigned to just 9. So because each x value has just one related y value, yes, even though it looks weird, yes, this is a function. All right. If the technical definition is getting you a little confused, think of a function as being a relationship. Okay. Let's say you're in a relationship. Let's let X represent males. Let's let Y represent females. Okay. And so think of a function as being a relationship where every single male has to be monogamous. The males have to be monogamous. The X values, not the Y's necessarily. So if we go through, we see that 1 is being monogamous, 1 is dating 4. We see that 2 is being monogamous, 2 is dating 4. Okay? And then we see that 3 is being monogamous, 3 is dating 9. Okay, so the definition says the males have to be monogamous. We're not going to talk about this young lady's scrupulous behavior. That's for another lecture. All right? But that's what the definition is. If each male is monogamous, meaning dating one person, then we have a function. All right, let's take it to this last example here. Is this relationship a function? Let's see here. Let's write out the ordered pairs. The ordered pairs would be 1, 4, 2, 6, also a 2, 9, and a 3, 9. Okay. Is this a function? Each X value can only be assigned to one and only one Y value. Well, here we see that 2 is actually going to 2 different Y values. Because of that, this is not a function. 2 is not being monogamous. And another way that you can tell if a relationship is a function or not is to look at the ordered pairs. We've already written them out. But if your X values repeat, when you're listing out all of the possible ordered pairs, if your X values repeat, that means no, you are not a function, because that means that that same X value is being assigned to 2 different Y values. Notice the previous example. We do not have repeating X values. That's why, yes, it was a function, even though it looked a little weird. And then certainly the first example also exhibited the behavior where the X values that I'm highlighting did not repeat. Therefore, yes, it was a function. So if you come across a question where they give you a listing of ordered pairs and they want you to know if it's a function or not, just look at the X values. If the X values repeat, you are not a function. All right, the last little bit I want to get into here is how do you determine if a graph is a function? So a graph is just a visualization of a relationship. It's a bunch of ordered pairs. All right. So how can you tell? Well, what we're going to do is we're going to utilize something called a vertical line test. And what a vertical line test does is if you imagine taking like a vertical pen, and what you're going to do is you're going to slide it through from left to right. And here, my green vertical lines here represents all the different times I slide through my graph here. If your vertical line intersects your graph at one and only one place throughout the entire domain, then we say it passes the vertical line test, which means yes, you are a function. So in this first example here, yes is a function because each vertical line is going to intersect that graph at one and only one place. How does that tie back to our definition? That means for each X value, there's only one corresponding Y value. But what about the second graph here? We notice here, there's going to be at least one place where my vertical line fails the vertical line test. Why? Because the vertical line intersects the graph at more than one place. What does that mean? That means that for whatever this X value is here, we actually have 2 different corresponding Y values. And we know that fails the definition of a function. So in this case, we fail the vertical line test, which means no, we are not a function. All right, folks, I'm going to see you guys in the next video.